This is a graphical presentation for assembly and erection of a fluidized bed sugar dryer cum cooler system with an inbuilt twin-stage dust collection system. Foundation for the dryer needs to be readied as per the drawings submitted for the system by VS Projects and System Engineers Private Limited. The foundations for various accessories of the dryer are as follows. 1. Foundation for base frame and exhaust hood. 2. Foundation for drive assembly. 3. Foundation for cyclone tank. 4. Foundation for primary tank. 5. Foundation for hot air blower. 6. Foundation for ID fan. 7. Foundation for cold air blower. 8. Foundation for centrifugal pumps. 9. Foundation for heat exchanger. 10. Foundation for drive motor. We must ensure that the master center line, in blue, which is common for the preceding feed equipment, and the base frame, matches with the drive center, depicted in yellow. Now the drive assembly must be mounted with the foundation bolts as depicted here. Carefully place the drive inside the foundation drive pockets, while maintaining the master center line. The feed side base frame subassembly, which is also the longer of the two subassemblies, need to be mounted with the foundation bolts as depicted here, and then carefully placed inside the foundation pockets for base frame, as shown here. The same procedure shall be repeated for the discharge and base frame subassembly, the shorter of the two subassemblies. The two subassemblies now need to be connected using the fish plates provided for bolting them together, and then welding them to make a permanent joint, one piece, using arc welding. At this point we must ensure that the top level of the base frame is leveled properly both longitudinally and horizontally. This can be ensured using a water level tube which is filled with either water or diesel for more accuracy. The procedure for the same is being displayed here, and needs to be checked throughout the length and width of the base frame. The center line of the base frame should also be matched with the master center line, to ensure there is no misalignment during assembly of the drive with respect to the base frame. The diagonal when measured from the far end points, as shown here, should be within plus or minus 5 millimeters. Once these things are ensured, the base frame can then be grouted. One must be careful to ensure the base frame does not move from its position during the settling of the concrete. Once the base frame foundation is settled and cured, 6 support channels of 150 mm width need be placed on top of the base frame, along the width, and equally spaced. Tack weld these supports to the base frame, as these are only temporary, and shall be removed once the erection work is completed. Place the feed side tray, the longer of the two subassemblies, on top of the support channels. Then place the discharge side of the tray, the smaller of the two subassemblies. Bolt the tray side plates together using the angle flanges provided at the ends of both the subassemblies. Also join the chassis together using the fish plates provided for bolting, and weld the two subassemblies to create a one-piece tray. Similar to the base frame, the chassis straightness must also be maintained during assembly. However, please note that since there is a heavy pin housing and a 20 mm thick plate at the center of the chassis, the tolerance for the chassis straightness can be a few millimeters off. Once the tray is assembled and complete, move the tray towards the feed side, till the back end of the feed side of the tray is 120 mm behind the base frame back end. We must also ensure that the center line of the tray matches with the master center line. Once the placement of the tray is complete, we can then mount the elastomeric rubber tensioners, as shown here. Please note that the M100 tensioners, the bigger ones, are meant for the base frame, whereas the M75 tensioners, the smaller ones, are meant for the chassis. The supporting arms should then be bolted together with the flats provided on the tensioner heads for their bolting. This procedure should be followed for all the tensioner slots on either side of the tray and base frame. Now we move to the final assembly of the drive before grouting. We once again ensure that the drive center is collinear with the master center line. The locking plate of the pin housing needs to be removed. The pin housing needs to be loosened to ensure that the pin can enter freely. We then insert the small end of the connecting rod, which also houses the bush between the pin housing. The pin can now be inserted, and the housing shall be tightened. The locking plates come in place and get bolted. The small end and big end flanges of the connecting rod are to be joined together using the high tensile hardware. The same procedure needs to be repeated for the other connecting rod small end. The distance between the two connecting rods is approximately 800 mm for dryer capacities ranging from 25 to 50 tons per hour. For capacities higher than or lower than this range, kindly check with VS Passe for the exact center distances. The distance from the master center line of the dryer, when seen from the end view, for each connecting rod is approximately 400 mm, and this distance must be ensured at both ends. Using the first base frame's tool center, from the feed side as reference, the center ideally is 250 mm from the back end of the base frame. We drop a plumb bob towards the drive center at 3030 mm at either ends to center the drive assembly longitudinally. This distance is standard for any capacity dryer provided the length of the base frame is 12 meters. Now place the master level on the shaft along the length at least 2 places to ensure that it is perfectly leveled. 0, 0. Now using the inside edge of the pin housing as reference, measure the diagonal distance between the inside edge of the pin housing on one end and the point derived from dropping the plumb on the shaft on the opposite end. Please note that the points derived on the shaft using the plumb should be equidistant from the master center line. Do this for either side and ensure that the difference in lengths between the two diagonal is within 0.5 millimeters. Once all of these checks are complete, we can move to the final grouting of the drive assembly. During final grouting, it is critical to ensure that the drive assembly does not move from the set position. Hence it is advised to use temporary supports to accomplish the same. Once the grouting of the drive assembly is completed, and the drive is firmly settled, we can move to mount the flywheels for the drive assembly. There are 2 flywheels, one is V-grooved which will be assembled towards the drive motor side foundation, and the other is flat, which will be assembled towards the non-drive side. Disassemble the locking plate from the flywheel, and mount the flywheel onto the shaft. Now match the keyway slots on the flywheel and shaft, and insert the key into the assembly. Now secure the flywheel by bolting the locking plate with the flywheel and the shaft. Repeat the same procedure for the other flywheel. We now move on to the assembly of the exhaust hood. For this we need to place 6 support square pipes of 50 mm width on top of the tray assembly, along the width, and equally spaced. Tack weld these supports to the tray assembly, as these are only temporary, and shall be removed once the erection work is completed. exhaust hood needs to be assembled as demonstrated here using the match markings provided on each of the panels. While placing the exhaust hood, one must ensure that the top cutouts are inclined towards the primary tank foundation. Also, we must ensure that the feed side end of the exhaust hood is in line with the tray assembly. The feed side of the exhaust hood can be easily located, as it is the one without the manhole cutout. Once the exhaust hood is placed on top of the tray assembly, the brackets can be welded to the sides of the exhaust hood by measuring and altering the length of the columns, as required at the site location. The top end of the column with the mounting plate is on tack weld, and hence the length must be altered from that side. The foundation bolts of the exhaust hood columns now need to be placed and grouted as depicted here. Now we place the primary tank on the designated foundation. We need to ensure that the round opening for the venturi is centered with the exhaust hood assembly. We now place the overhead round duct with square nipples on top of the exhaust hood on one side. It will then be bolted with the flanges provided on top of the exhaust hood. We now bolt the common square duct to the header placed on one side. The other half of the overhead header will then need to be placed and bolted with the square duct. The height of this duct will give us the reference for the venturi height, and we can alter the distance piece provided to exactly match the height of the venturi with the square duct. Now place the venturi on top of the distance piece, and bolt it with the square duct at one end, and the distance piece at the bottom end. Sparger will then be welded with the toplet of the venturi, and placed inside the venturi. We must ensure at this point that the spraying holes of the venturi are located just below the top square cutout of the venturi. The cold air blower is now to be placed onto its designated foundation after fitting it with the foundation bolts, and then needs to be leveled and grouted. We then proceed to mount the cold air header duct, which has 6 nipples at the bottom. This header can be supported using the exhaust hood columns to provide stability. The nipples at the bottom of the header are to be bolted with the 90-degree bends so that the other end of the 90-degree bend matches with the nipples jetting out of the tray. A gap of approximately 200 to 250 millimeters is to be maintained between the loose end of the bend and the nipple jetting out of the tray. We then place a rubber bellow to create a flexible joint between the bend and the tray and secure the bellows using C-clamps. Repeat the same procedure for all the nipples on the cold air side. Now carefully place the connecting piece between the cold air blower and the header duct. This connection duct is bolted to the blower outlet using the flange and welded to the header at the center after making a suitable cutout. We then move on to the centrifugal pumps assembly. Mount the motors onto the frame and put the foundation bolts into place. We then place the frame on its foundation grouted after leveling. We then move on to the placement of the cyclone tank. The cyclone tank should be placed on its foundation, ensuring that the tangential entry matches with the rectangular opening provided on top of the primary tank. We then place the L duct in place, which is a 90-degree bend with a rectangular cross-section. Bolted at one end with the tangential entry, and the other with the primary tank's rectangular opening. We then place the heat exchanger, ensuring that the inlet of the heater faces air blower, onto its designated foundation, and grout it after leveling. An easy way to identify the hot air blower is that its orientation is bottom horizontal, and usually has a bigger motor when compared to the cold air blower. Now, similar to the cold air blower, we place the outlet of the hot air blower. The outlet of the hot air blower has the same dimension as the inlet of the heater. Hence these two must be at same level, and the height adjustment can be done altering the length of the mounting columns of the heater before grouting it. Place the distance piece between the heater and hot air blower, and bolt it at either end. Now we place and assemble the header with the 90-degree bends and bellows, following the same procedure as we did for the cold air side. The only difference is that we center the header using the outlet of the heater as reference both horizontally and vertically instead of the outlet of the cold air blower. We bolt the connection piece onto the heater outlet and weld it at the other end to header. After making a suitable cutout for air to pass, we can now move on to placing the ID fan onto its foundation, after mounting it with foundation bolts and grout it. We now need to connect the top flange of the Cyclone with the ID fan inlet. For achieving this, we will need these connection pieces bolted together, the top cone, 3 90-degree bends, and 2 distance pieces. Once bolted together, these can now connect the top of the Cyclone with the ID fan inlet, as depicted here. Since it isn't feasible to animate the recirculation piping, we request our viewers to pause this frame showing the complete recirculation piping along with the legends for each connection, and follow a similar pattern to do the recirculation piping at your site. Thank you for watching.